we will start discussing functions and just reviewing over what we've done with functions before. So let's start by doing some definitions. So first we want to define what a relation is. A relation is just a set of ordered pairs. So if we have, usually we have to do x's and y's. If we have sets of x's and y's together, that's a relation. A function is when we take a relation and it's a relation where for every input there's only one output. Every input, usually that's the x, there is only one output. Usually that's the y. So x is usually what we put into the function, y is what comes out. So a function is where you take that ordered pair and you only have the x's paired up with exactly one y. So we want to test to see if a relation is a function. The first thing we have used was with graphs, we've used the vertical line test. And if you can draw a vertical line and that vertical line hits the graph at 2 or more times, it is not a function. So if you can draw a vertical line that passes through the graph the 2 or more times, it is not a function. So if we look at these two graphs, for instance, as examples, this first one, if I draw a vertical line out here, it only hits it once. But if I draw a vertical line over here, it will hit it even 3 times. So if it hits it 2 or more times, it is not a function. Now this one over here, every time you draw a vertical line, it will only hit it once. So this is a function. It passes the vertical line test. So basically the vertical line test either passes or fails. If it passes and does not hit the graph twice, it is a function. If it does not pass, if it hits it 2 or more times, it is not a function. All right, now let's look at where we do ordered pairs instead to test functions. So what you want to look at with ordered pairs, whether you've got a set of ordered pairs like this, like a relation, or in this way where we do it as a chart, or maybe more as a diagram where this is the input, the x's, this is the y's implied to be inputs and outputs. When you look at this, you want to make sure you check to make sure that the x's are never repeated. So the x's are not repeated. Means it's a function. So in this ordered pair, that would mean the inputs are not repeated to pair with a different output. So here, notice that these 9s, these are the inputs here. So this 9 here, this is a repeat of the x's. So when there's a repeat of the x's, it's not a function. Now this one, this x is paired with that y, this x is paired with that y, this x is paired with this y. The y's are repeated, that's okay. The outputs can be repeated, but the inputs cannot be repeated, so this is a function because the x's are not repeated. And this last one, notice 1 goes with 5, 2 with 6, 3 with 6, and 4 with 7. The 6 is repeated, that's an output, it can be repeated. But in this one, the inputs are never repeated, so this is a function. So that's how you test with more ordered pairs or charts or tables. Now, let's talk about the notation we've used with functions before, just as a review a little bit. So our notation is usually in the form of putting an F with a parentheses and the X afterwards, or other letters. We could use G or H. Usually we'll use some letter, and then X is usually our input, though we could use a different input like say a T, but this is the notation we use. This is read F of X. Okay, so when you look at that notation, it means F of X. F of X equals usually a rule. So usually we'll go F of X equal to some rule. The rule could be, as an example, if we had F of X equal to, let's do 10x plus 3. So as an example, you would have, by the way, this is, if you read this, it's just like saying, y equals this. Y equals 10x plus 3. So if we think of x's and y's, it's the same thing when we have the f of x equals, it's like saying y equals. So when we say f of 7, so here's an example. If we do f of 7, that means substitute 7 in for x and find the y, find the output. So this would be put in 7, you've got 10 times 7 plus the 3, which would be 70 plus 3 would equal 73 for doing that. So just a reminder that this would be our input, this is the output, what comes out of it. That's what functions do. And when I put in 7, I only get out one number. I get 73. I don't get two other numbers. Now, composition of functions are something that we've worked with before briefly. So let's review over a little bit, and we'll build on it this chapter, because we'll do a lot with functions. Functions, Algebra 2 is a lot about functions. So composition of functions, what we usually do is we say the second function is substituted into the first function. So you take the second function, like if we list this, g of x is the second function, we put it into the f function substituted in. It can be listed this way also with a little open circle in the middle. It's not, if it's closed, it's multiplication, but if we have an open circle between the f and the g, that means f of g of x. And same thing here, if we put a parentheses around it, it means the same thing. So these three are this notation for the exact same thing. The way we read this is f of g of x. That's how that notation is read. All right, so let's take a look if we've got this example here. Let's try this first one here. If you do g of f of 7, what you do is ignore the g of x for now and just think about the f of 7. Think about what the inside is, because we're going to put that into the g function. So we're going to first of all find f of 7. That means put it into this function. 7 is the input, so we're going to have 7 squared minus 10 is equal to 49 minus 10, which equals 39. So f of 7 equals 39. So if I'm trying to find g of f of 7, this problem, I'm going to put in where there's f of 7, I'm going to put a 39 instead, because that's what it's equal to. Notice that one goes into the second function. And so I'm going to put this, the 39 is going to go into the g of x. So 39 goes into g of x over here, so it's going to be 2 times 39 plus 5, because that's what my g of x is equal to. So 2 times 39 is equal to 78, plus 5 is equal to 83. So that's what the answer to that example would be. Do the inside part first, substitute it into the first function listed there. Now, when we list this is the same thing. I prefer using this notation. I think this is easier to understand. That means the g of x gets substituted into the f of x. So what I'm going to do is I'm going to take the f function here, and so when I'm doing this, I'm going to take wherever there's an x in this, the input, wherever there's input, I'm going to substitute in for it the g of x. So the x comes out, put it in parentheses, put that g of x in its place. So I'm going to put 2x plus 5 as the input for it. Now I've got to multiply out 2x plus 5 times 2x plus 5 because it's squared. And if you were to double distribute that, multiply out 2x times 2x, 2x times 5, 5 times 2x, etc., you're going to get 4x squared plus 10x, and then the 5 times the 2x is another 10x, and then 5 times 5 is the 25, minus 10. Now we combine like terms, and we get 4x squared plus 20x, and then 25 minus 10 is plus 15 for my answer. So that's what you get when you put those together. So that's composition of functions. Take the second function listed and put it into the first one listed. All right, now, just a reminder of what these families of functions. So again, Algebra 2 is a lot about functions. We're going to build more functions into our course as we go on. The ones that we've already done linear, absolute value, quadratic, polynomial, and rational. The basic graphs of these look like the following. If it's linear, we're going to have a graph looking like this, just a line. Okay, if it's absolute value, we're going to have it look like a V. If it's quadratic, it will look like a parabola somewhere. If it's polynomial, that means we'll do 2 of them. If it's an odd polynomial, remember an odd exponent, it's going to have one going down, the other one going up with it. If it's even, they're both going to be the same direction, just like this one, this quadratic. So I'll put one going down, and whether it goes down or up depends on the leading coefficient, whether it's positive or negative, just as a review. And then lastly, the rational ones. Again, there are many forms of this, but usually we look at some type of asymptote, and we have the graph looking like a type of hyperbola in 2 of the different quadrants. Sometimes it's in different areas, maybe 3 or 4, but it gives sometimes asymptotes, sometimes open or closed dots as part of the graphs.